Hi, I'm Professor G, teaching you physics. Welcome back. In today's lecture, we will be covering topics on forces that causes acceleration, friction, and then the difference between mass and weight, and eventually arriving at Newton's second law. Before we start, please make sure to subscribe to my channel, Physics Friendly, and also hit that bell icon for my other upcoming video notifications, and feel free to share with your family and friends. So we've already seen the concept of acceleration. Now we know acceleration is defined as change in velocity over time. So change in velocity is final velocity and initial velocity over given time. Now the question is, what produces acceleration? Acceleration is produced by force. Here is an object of mass m, and let's apply a force of, let's say, 10 Newton. So as soon as I start applying a force, the object starts to move. So what does that mean? That means force causes an object to accelerate. So as soon as I apply a force of 10 Newton, there comes our acceleration. Force causes acceleration. So now the Newton's law that we talk about, it links three important physical quantities for us, which is acceleration and then the mass of an object, correct? So force that causes acceleration. Force causes an object to accelerate. This means higher the force, higher will be the acceleration. Yeah. Lower the force, lower will be the acceleration. So if you apply 10 Newton force, then the object is going to accelerate 3 meter per second square. And then you lower the force, let's say 2 Newton, and then the acceleration goes down accordingly. So this relationship that we are talking about is called as directly proportional. So we say force is directly proportional to the acceleration of an object. So this symbol that we have is called as directly proportional. This is an expression, proportionality expression. We're going to move this expression to equation form. So I'm going to introduce the equation symbol here, and then we have acceleration on the right hand side of the equation. But then when we move from expression to equation form, we have to introduce a proportionality constant. So in this case, mass is that proportionality constant. And then we have this particular equation that we have is called as Newton's second law. So let's look at frictional force, or it's also called as force of friction. So when an object moves, it tends to slide on the floor. So there comes the frictional force between the floor and the object. Now let's say there are two objects which are sliding on each other, then the frictional force acts between those two given objects. Now let's look at the direction of the frictional force. The direction is always going to be opposite to the motion of the given object, right? If the object is moving in positive x direction, our frictional force is always going to be acting in negative x direction. Now, for frictional force, it's denoted by small letter f. You see how we had capital F for the force, now we have small f for the frictional force. And I already talked about this. Direction is always going to be opposite to the motion of the given object. Units, since frictional force is a type of force, the SI unit is going to be newtons. Capital N is what we use for newtons. So for example, frictional force can be 10 Newton. Right? So let's take an example where we have an object of mass m. Let's say this applied force is, I don't know, I'm going to still take 10 Newtons. So applied force is 10 Newtons. Now let's look at the frictional force. We said frictional force is always going to be acting in the opposite direction to the motion of the object, right? So you have applied force, which is 10 newtons in this case. And then when you apply a force causes acceleration from Newton's second law. So the object is going to move in positive x direction. So that means your frictional force will be acting opposite to the applied force in this case. So this is where the frictional force will be acting. So we already saw frictional force, right, 10 newtons. So this will be the magnitude part of the frictional force, and direction when both of them are there to describe the frictional force. So frictional force is nothing but a vector quantity. Right. So there are multiple types of frictional force. So let's look at them. Small f denoting friction. There are two types of friction. One is static friction, another one is kinetic friction, or it's also termed as sliding friction. Sliding friction, when two objects slide, right? There comes the friction between them. Now static friction is denoted by, we have small f and static, so with a subscript s. All right. Kinetic friction, small f again, but with a subscript k. Whenever an object is at rest, it has static friction. When an object is moving with constant velocity, we always say that kinetic friction is always lesser than static friction for a reason, because it takes more force to get the object going from rest than to keep the same object moving at a constant speed, right? And then let's take some examples. And let's say I have an object of mass m, and I apply a force of, let's say, 1000 newtons. So this is your applied force, right? And then I have a frictional force which is acting, right, in the opposite direction. The direction is always going to be opposite to the motion of the object, not opposite to the applied force, but frictional force is always going to be opposite to the motion of the object. Now let's say this is given as 700 Newton. All right, so now if I have to calculate the net force, do you guys remember net force? Net force is the combination of all the forces that's acting on a given object. So that would be 1000 Newton, right, plus 1000 Newton, because applied force is acting in the positive x direction, minus 700 Newton. So we have our net force equals to 300 Newton acting in the positive x direction, hence have that positive symbol there, and this is your net force for the given object. So now let's look at the difference between mass and weight. So before moving there, let's look at acceleration. We know acceleration depends on applied force. Force causes acceleration. Then an object can slow down because of the frictional force. So definitely, acceleration is dependent on the frictional force. Now, the third important one is acceleration is also dependent on inertia. Now, what is inertia? Inertia is just the resistance of an object to change its motion. So greater the mass, greater will be the inertia of an object. Now moving on with the mass here. Mass, we defined it in two ways. Mass is defined in two ways. So one first definition is the quantity of a matter in a given object is defined as mass. Now the second one that we have seen is measure of inertia that object exhibits to start, stop, or even change the direction of the given motion. Units for mass is kilograms or kg. Second physical quantity that we are looking at in here is the weight. The weight is nothing other than our gravitational force that we feel from the surface of the earth. So it's either gravitational force or force due to gravity, both are same. F subscript G stands for force due to gravity. W, the weight, is same as gravitational force. So weight is always measured, or the units for weight is going to be Newton, because weight is a type of force. Gravitational force or force due to gravity, it's measured in newtons, capital N. Now the relationship between mass and weight is given in this particular equation. So this is what we have now. Weight equals mass times gravitational acceleration. G is our gravitational acceleration. Let's say gravitational acceleration is absent, right? Then in that case, we have a relationship between weight and mass where weight is equal to mass. Or in other words, weight is directly proportional to the mass. What that means is higher the weight, right? Higher will be the mass of the object. Lower the mass of the object, lower will be the weight. So this relationship is called as directly proportional. So in the absence of gravitational acceleration, weight of an object will be equal to the mass of the given object. Okay, so what that means, let's say if mass is doubled, then what happens to the weight? It has to be doubled as well. Yeah. How about if mass is half, the weight half as well? Yeah. So that kind of concludes and gives us a more understanding of mass as well as the weight. Mass, another important thing is mass is an intrinsic property, internal property of an object. Weight is not an internal property of an object. What that means is, let's say I take an object, right, and if I place that object on earth, object is going to experience a gravitational pull from earth. So that means gravitational acceleration on the surface of the earth is 9.8 meter per second square, and that holds good. Now I can take the same mass and keep that on different planet, let's say Mars, right? Mass is exactly going to be same. Mass is not going to change. But what changes? Weight changes, because that is equal to mass times gravitational acceleration. So if it's placed on Earth, gravitational acceleration is way different than if the object is placed on the Mars or any other planet.